Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help out our channel, and it also helps us reach others who want to test their math skills with these types of test questions. So this will be the 16th part in our series, and what we have going on with this one is that we are going to be testing calculus and trig identity skills. So we have to perform the following derivative, which is shown here on the left as the derivative with respect to t of the natural log of the cotangent of 4t squared minus 1, given that the cotangent of 4t squared minus 1 is greater than 0. And we are also told that we have to evaluate this such that there is no fraction as our answer. So whenever we get an answer, we cannot have a fraction going on. We cannot have something divided by something. So looking at this right away, working on the derivative, we are going to have to apply the chain rule right away. So with the chain rule, we're going to have to do some substitution here. And let's set a u variable equal to everything inside the natural log. So this would be the cotangent of 4t squared minus 1. And let's set an f variable to the natural log of everything inside here, which is now u. Alrighty, so when we apply the chain rule, this derivative now is the derivative of f with respect to t. And this is going to be the derivative of f with respect to u multiplied by the derivative of u with respect to t. So writing all this out, we have d du, which is of the natural log of u, and then all of that multiplied by d dt cotangent of 4t squared minus 1. Alrighty, so let's work on the natural log one first because it is the easiest of the two. So whenever you have the derivative of the natural log of a variable, that is simply just going to be 1 over u. So d du of the natural log of u is equal to 1 over u. Alrighty, well, what is u equal to? Well, it's the cotangent of 4t squared minus 1. So let's go ahead and plug that in for our u variable here. So this would just be 1 over the cotangent of 4t squared minus 1. Alrighty, so let's take this and then plug it back into our equation down here. So we're still going to have our derivative of f with respect to t is now equal to 1 over the cotangent of 4t squared minus 1 multiplied by d dt cotangent of 4 squared minus 1. All right, so for this portion, that is the second portion right here, we are going to have to apply the chain rule once again. And we are once again going to have to set some new variables. So let's set v is equal to everything inside the cotangent here, which is 4t squared minus 1. And then let's set a variable g is equal to the cotangent, which would now be v, so cotangent of v. So we're going to have to do the chain rule separately for this portion and then plug everything back in here eventually once we get this little individual derivative using the chain rule. So switch back to blue, please. Thank you. So we are going to have dg dt is equal to dg dv multiplied by dv dt, which is equal to d dv cotangent of v multiplied by derivative with respect to t of 4t squared minus 1. All right, this is not terrible. So the derivative of cotangent of v will be the minus cosecant squared of v. And then the derivative of 4t minus 1, well, this 1 over here disappears because it's a constant. Every time you have a variable you're taking a derivative of with a constant, just becomes 0. So this essentially is just going to be 2 times t squared because it is of the version of d dx of a x to the b, which is just going to be b times a x b minus 1. So 4t squared becomes 8t. All righty. So now let's plug all this right here back into this portion up here. So switching back to red, we will have the derivative of now f with respect to t is equal to minus cosecant squared of v. Well, what is v? Well, v is 4t squared minus 1. So we'll just go ahead and plug that in. So 4t squared minus 1. And that's going to be times 8t. And then all of that will be divided by the cotangent of 4t squared minus 1. Now, we could leave this as our answer if we were not tasked with the second statement in the problem saying evaluate such that there is no fraction as the answer. Well, what do we have? We have a fraction as an answer here. So we are going to have to use some trig identities because this is the derivative, but we have to turn it into a non-fraction answer. So we're going to have to simplify this even further. Well, we can use some trig identities here. And well, the cosecant of theta is equal to the 1 over sine theta. So the cosecant squared of theta is equal to 1 over the sine squared of theta. And since we have cotangent here, let's try to get rid of that as well. So we would have the cotangent of theta is equal to the cosine of theta over the sine of theta. So let's plug in these identities here for our trig identities into this derivative, and let's see what we have. And what I'm going to do is I'm going to separate everything out into its little portions here. So I'm going to have minus 8t multiplied by cosecant squared of 4t squared minus 1. I don't know why I made my brackets so large. And then 1 over the cotangent of 4t squared minus 1. So I can take the 1 over sine squared, plug it in here with my theta being what's inside the brackets here, 4t squared minus 1. And the same thing for cotangent here, using cosine and sine of theta, where this little portion right here is my theta. So what I would have, let me scroll down just a little bit more. So what I would have here is I would have minus 8t multiplied by 1 over sine squared of 4t squared minus 1. And then I would have that multiplied by, well, since the cotangent is 1 over the cotangent, we just flip this ratio of cosine and sine. So that would be multiplied by sine of 4t squared minus 1 all over cosine of 4t squared minus 1. Well, when we slap this thing back together here, this sine 4t squared of 1 will disappear, and this squared version of sine disappears as well, and we're just left with the sine in the denominator. So this ends up being minus 8t all divided by sine of 4t squared minus 1 times the cosine of 4t squared minus 1. Well, that is still a fraction there, so not quite there just yet, but we can apply another trig identity in order to try to get rid of this fraction. So the sine of theta times the cosine of theta, which is essentially what I have here if I take theta as 4t squared minus 1. Well, this is equal to the sine of 2 theta all divided by 2. So let's go ahead and plug this in with this identity. So we would have minus 8t all divided by sine of 2 times 4 times the square root of, or square root t. Let me repeat that. It'd be sine 2 4t squared minus 1 all divided by 2. Well, we can take the 2 to the top and we end up with minus 16t now, divided by the sine of 8t squared minus 2. Once we take this 2 through that, well, we are still a fraction here. We're not quite there yet, but we're almost there. Well, this essentially is 1 over sine of theta. Now theta is 8t squared minus 2. Well, what is 1 over the sine of theta? Hey, it's right there. I wrote it earlier. We're back to the cosecant. Yeah. So applying that trig identity there, we would end up with minus 16t times the cosecant of 8 squared minus 2, or 8 squared. Let me repeat that. We would end up with minus 16t cosecant of 8t squared minus 2. And finally, our derivative that we found up here is now in a non-fraction form, and this would be my final answer right here. So I hope you enjoyed this video, and I hope you learned a new math skill along the way. And if you want to test your abilities even further, please check out the other videos on our channel. Also, if you haven't done so already, please like this video, leave a positive comment below, and subscribe to the channel because all of that does help us out greatly. Thank you for watching, and I hope you have a fantastic day.